Section 5.2, Applications of Exponential Functions. So first, there's a number of different applications we're going to do. The first one is population growth. P of t equals p sub 0 a to the t power with a greater than 1. This is the formula for population growth. P of t is the population at time t. P sub 0 is the population at time t equals 0, which is also known as the initial population. The sub 0 is used a lot for initial value of something. And you can see why is the population at time t equals 0. If you just plug 0 in for the time in the formula, you get P of 0 equals P sub 0 a to the 0. A to the 0 is 1, so and P sub 0 times 1 is P sub 0, so we get P of 0 equals P sub 0. So that's why P sub 0 is the population at time 0. A in this situation is called the growth rate. So for example, if A is 2, that means that P doubles for each increase of 1 unit of time. So say the unit of time is a day, then if A equals 2, then the population doubles every day. So example, suppose there are 10 flies in your house. 2 weeks later, there are 14 flies. Assuming the number of flies in your house increases exponentially, how many flies are there in your house after 20 weeks? So the unit of time is weeks. We start with 2 weeks. So we'll write out the formula. P of t equals P sub 0 a to the t. There's two sets of information here. For both of them, the initial number of flies is 10, so P sub 0 is 10 for both sets of information. The first set of information is there's 10 flies in your house, and 2 weeks later, so the time is 2, there's 14 flies. So P of 2 is 14. So P initial is 10, time is in weeks, and we get 14 equals P of 2, which is 10a squared, because it was after 2 weeks, right? So a squared. So this gives us a squared equals 14 over 10, which is 1.4. And then a is the positive square root of 1.4, because a has to be a positive number. Remember, the base is always positive. So then we take that a and rewrite the formula from here with the new a, but we're still going to use the same initial number of flies. So we get this P of t equals 10 square root of 1.4 to the t power. So then P of 20 at 20 weeks, which is what they're asking for, is 10 times the square root of 1.4 to the 20th power, or 10 times 1.4 to the 10th power, right? And that gives me 289 flies. I got 289 and a quarter flies, but you don't really have a quarter of a fly, so I just rounded it off to the lower integer. Just cut off the decimal part.